Equations of motion are the important equations that is used in A-level physics to solve for accelerated motion problems. These equations are commonly known as the SUVAT equation. In this video, we are going to learn how we can derive these equations. But let's take a look at those equations first. First equation of motions, V equal to U plus AD. Second, S equal to half times U plus V times T. Third, S equal to UT plus half AD squared. And fourth, V squared equal to U squared plus 2AX. Why are these equations called as the SUVAT equation? Because they contain the quantity S, U, V, A, and T. S is the displacement with the unit in meter. U, initial velocity with the unit meter per second. V, final velocity meter per second. A is the acceleration meter per second square, and T, time in second as the unit. Now, let's see how are these four equations derived. First equation of motion, V equal to U plus AT, is derived from the definition of acceleration. Acceleration is the rate of change in velocity. Thus, we can get the formula A equal to V minus U over time. By do a cross multiplication, we will get AD equal to V minus U. And then we can change the subject of the formula as V, and we will get V equal to U plus AD. And here is our first equation of motion. Let's go to the second equation of motion. This second equation of motion is derived from the velocity time graph. By taking velocity as the y-axis, time for the x-axis. Okay, now let's imagine there is an object that moves with an initial velocity u, and it reaches a final velocity v, given a certain period of time, t. Then from these conditions, we will get a graph showing the motion of this object. To get the displacement out of this graph, we can find the area under the velocity time graph. And as we can see, the area of this figure is a trapezoid. What is the formula of trapezoid? The area of trapezoid is the sum of the parallel sides over 2, and then we times with the height. Okay, so let's try to find the displacement. The sum of the parallel sides in this figure are the sum of u and v. So we have v plus u over 2. And then the height of the trapezoid is given as t. Then we can times with t. And here we go, we get the second equation of motion. Let's move on to the third equation of motion. This third equation of motions can be gained from first equation and second equations combined together. We do it by substituting the v terms in the second equations with the u plus AD from the first equation. after substituting, we will get the term s equal to u plus 80 plus u over 2 times time. Simplifying the terms inside the brackets will give us this expression. And further simplifying, we'll have s equal to u plus half 80 times with t. And finally, by times the t inside the bracket, we will have s equal to ut plus half 80 squared. And here is the third equation of motion. Let's go to the fourth one. So the fourth equation of motion is derived from the first equation, v equal to u plus 80. And then we can take the square of both sides. So we will get this expression. And expanding the right hand side, we will have v square equal to u square plus 280 plus a square t squared. Then, from this part of the expression, we factorize 2a out from the expression. Then we will get this expression. As you can see, the terms inside the bracket are actually the equations of the third equation of motion. Then we can change that as s, and we will get v square equal to u square plus 2as. And here is our fourth equation of motion. Alright, so those are the way we derive the four equations of motions. So it's very simple, right? Okay, thank you for watching. So please stay tuned for next videos.